Hi there, we're going to talk just a little bit about Lesson 37. Lesson 37 covers the area of a triangle and rectangular areas. And there's quite a relationship between triangles and rectangles. I don't know if you have ever really thought about it too much, but there's kind of a stunning relationship between the two. There's some vocabulary you want to write down. The altitude of a triangle is the height of a triangle. It is what comes up from the bottom, the base of the triangle. It comes up at a 90-degree angle. The base of a triangle is generally known as, it would be where the altitude or the height intersects into. You can usually tell because it'll have one of those little 90-degree, has a 90-degree box like that. So it looks like that, and there's this would be the base, and then right here there's usually a 90-degree box, and then that's the height. Okay, the height is also known as the altitude, and I've got quite a few of these drawn here. You'll want to maybe put some of them into your notes, not necessarily all of them, but you'll want to put some of them into your notes. Here's a drawing of a base and a height. Two basic same triangles drawn. Basically one's drawn one way and the other one is basically flipped. So it's drawn the other way. Okay. And then there is another style of triangle here where you have the height on the side and the base here going across here. Here is another triangle, and notice the 90-degree box is here, so your height actually intersects there. Okay, and that's the height, and this is the base. Just depends on how the triangle is drawn. Here's a couple more that's kind of interesting. Here's the base, and then the height is actually drawn outside of the triangle itself. We could try to draw the height somewhere else, but this is the place that it makes the most sense and it's the easiest for us to see. If you were to try to draw it, you would have to draw it like across here, and it would be rather awkward. Here's another one, has a base right here. This is very much an obtuse triangle, very, very obtuse. Its major angle is very large. Here is the height for that triangle. It is also drawn outside of the space of the triangle. Definitely would put some of those in your notes because you're going to run across those and you'll be looking to try to figure out how to find the area of them and you won't know. Okay, now when you think of a triangle, what you really should be thinking of is a rectangle cut in two. And the reason I say that is because if you start out with a rectangle that looks like, you know, just basic rectangle looks like this. Okay, and if you were to take that rectangle and just draw a diagonal across it, you would see right away that these both are triangles. Well, if you remember how to find the area of a rectangle, it is length times width or base times height. You could also say base times height. Well, if we look at this, if we were able to cut it apart, here's our 90-degree angle, here's our height, here's our base. Here's our other 90-degree angle, here's our height, here's our base. We have two triangles. If I found the area of this rectangle, it would be length times width. Now, if I divide that by 2, I've just found the area of each of the triangles that make up that rectangle. Kind of a cool thing. Kind of a cool thing. Okay, we have a little activity I just want to show you just a little bit. And really what it shows is how we can manipulate triangles. So I'm going to lay it here on here. Hopefully you can see this well enough. Okay. So here we go. We have basically a rectangle. And what I've done with this rectangle is I have cut a triangle out of it, haven't I? I've cut a triangle out of it. And the triangle that I've cut out of it is yellow. Okay. And what I cut off of it to make that yellow triangle were two more triangles, didn't I? I cut this off here, I cut that off here. This triangle here goes across here. Here's your base, and here's your height. Now, I said that every triangle is just half of a rectangle. So let me prove that. I'm going to take the pieces that I cut off, okay, and then I am going to turn those pieces just a little bit, and I'm going to lay them like this. And guess what? It's really true. It's really true. If I take a rectangle, and even if I cut off two pieces that are seemingly kind of odd like that, to make a triangle, the two pieces that I cut off, these two pieces that I cut off, cover up the original triangle. So I actually have cut it into two exact halves. So that is kind of cool, and it works out pretty well. Okay, I did that activity. Finding the area of a triangle is not really all that difficult. We just have to make sure that we know what the base and the height is. Okay, in this case, right here, we have a triangle that has a height of 4, and then this is our base right here. It is 5. So if we use the formula that we derived earlier, that base times height divided by 2 will give you the area of a triangle. And the base is 5, the height is 4, so it's 1/2 of 5 times 4. You could have written it 5 times 4 over 2 also. So it's 1/2 of 5 times 4, which is 20. 1/2 of 5 times 4 is 10. So the area is 10 centimeters squared, since this was measured in centimeters. Always have to label area with the squared, because it really is square. It really is square units. Okay, a couple of the things that we need to talk about that are related to this particular topic are irregular rectangular figures and their areas. Now these are kind of fun. I always used to like these because the fact is that everybody does them just a little bit different. So the basic formula to find the area of a rectangle is length times width. Now, it just depends on how many lengths and how many widths there are, and what's been cut out and what hasn't been cut out. If you look at this particular figure here, we have two basic figures, or at least I see two. I'm sure you could see more than that, okay? But the smaller figure is right here, okay? And the larger figure is over here, okay? So if we use a formula that we have used before to find area of a rectangle, we have this area, the area that's 5 times 12, which makes this 60 inches squared. And then we have the area of the larger area, which is here, which is 16 by 22. So 22 times 16 makes this 352 inches squared. Now, larger, smaller, larger, smaller. Add the two together, and you end up with the total area being 412 inches squared, or 412 square inches. Area, kind of a weird thing sometimes. Sometimes you even have to figure out dimensions. Depending on how the problem's drawn up and how you look at it, you might have to do a little bit of work. For instance, on this particular irregular figure, you know that this is 14 tall. That's the height of this whole site. You also know that from here to here it's 4. So how in the world are we going to figure out what this is from here to here, so we have a height for this bottom bigger rectangle? Well, if this is 4 and this is 14, we could take 14 minus 4 and get 10, and that would give us our length here. Now that's all fine and well, and that really solves our problem. We could, if we wanted to, find this length here, but we don't need to because we already have this 20. So this piece, the piece that I am shading in green, okay, this piece has an area of 20 times 10. That's the green, that's the larger rectangle. this other rectangle, the one that's on top, that I'm shading in blue, it has an area of 15 times 4. Well, 20 times 10 today is 200, and 15 times 4 is 60. So if you add it together, you get 260 square units. Because I don't have any measurement on here, I don't have centimeters or meters or inches or anything else. So when you don't know, just write square units. Does that make sense? I hope it does. Okay? One more drawing that I'd kind of like to talk about. To share all the different ways that you're going to try it in class. Okay? Thanks a lot. Have a great day and talk to you later. Bye.